Hi. This is how you do number five. Number five. You have to write a balanced chemical equation: hydrochloric acid and sodium carbonate. Hydrochloric acid and sodium carbonate. This is a double displacement reaction. Okay, I will balance it. Okay, but you see this? H2CO3? Of course, that disappears because it's aqueous, and you get water and carbon dioxide instead. Right, so now it is balanced. Now I can do the problem. I want percent yield. Okay, so if you want percent yield is your experimental yield minus divided by your theoretical yield. So let's find the theoretical yield first, shall we? How much? It looks like we have an amount of sodium carbonate here, but the amount of hydrochloric acid is not specified. So in this lab, you probably remember we used a lot of hydrochloric acid. In fact, you kept on dropping hydrochloric acid into your dish until it stopped fizzing, meaning this was not the limiting reactant, it was this. So let's find the amount of sodium carbonate by subtracting this information from, no, this information minus this information. So this is the dish plus sodium carbonate. This is just the dish. If you want sodium carbonate, well, you got to get rid of the dish. So subtract this from there. So that is 48.216 minus 47.861. This is in grams. So I get, there's no calculator here. Here, I'll just 47.861. So this is 5, this is 5, this is 3, okay, 0.355. I hope that's right. So that's 0.355 grams. That seems like a very small amount. Oh well. Of sodium carbonate. So if you have 0.355 grams of sodium carbonate, you can now figure out what the theoretical yield is. So if you start with 0.355 grams of sodium carbonate, you need to know the molar mass of sodium carbonate. And then we'll have moles of sodium carbonate. And once you've got moles of sodium carbonate, you can convert that into moles of sodium chloride like this. 1 mole of sodium carbonate, 1 because there's 1 here, and that makes 2 moles of NaCl. Okay, so now we have moles of NaCl. Now the theoretical yield is going to be grams of the NaCl. The reason why I'm concentrating on NaCl and not carbon dioxide or water is because it says here after boiling off all liquids. So there isn't going to be any water, and we didn't collect any carbon dioxide because it's a gas, and we didn't use a tube and an upside down piece of glassware and water. We didn't do that for this. So it is sodium chloride that we're going to be looking for here. So 1 mole of sodium chloride, and the molar mass of that is 58.44 grams. Okay, Now I just need the molar mass of sodium carbonate, and I'll have to get that for you. Of course, on the final exam, you will be using the periodic table to add up the molar mass of sodium carbonate, 105.99. It's necessary to use the periodic table given on the exam because the masses are slightly different there compared to other periodic tables. Now, just the calculation is left. You do 0.355 divided by 105.99 times 2 times 58.44, and you get 0.391 grams. So this is 0.391 grams of NaCl. That's the theoretical yield. So that number goes in here. All right. Now we got to figure out the experimental yield, which is much easier. To figure out the experimental yield, we're going to get the mass of the sodium chloride. So here we have dish plus sodium chloride. You just got to get rid of the dish. So it's this number minus the dish, which is this number, right? 48.206 minus 47.861. 48.206 minus 47.861. And that's 0.345. So 0.345 grams are up here, and this was 0.391. So this is divided by 0.391 grams. Of course, it's a percent yield, so you have to multiply by 100. So 0.345, 0.391, and that's 88%. Three significant figures, so 88.2%. 88.2%. That's a respectable yield. 88.2%. So I'm not sure if that's actually the correct answer, but that is how to find the answer. Should we just see if this is the correct answer? I'm not going to put these. Oh, here we are. All right. So what happened? Oh, here it is. So 88.2%. Looks like that was not the correct answer. 88.1%. Okay. This the on the final exam, if you're off by such an amount, just off by the last significant digit, 1 unit of the last significant digit, that is going to be okay. All right. Yes, I remember I made this answer, 88.1, using the periodic table given on the exam. And the periodic table given on the exam is slightly different from other periodic tables. And so that must be why the correct answer is 88.1 instead of 88.2. Thank you.